It's the link again. All right, so yep, I think we're good. Okay. So sorry about that delay. Sorry for that delay. I had to get that information out so that we can inform other family members and let them know that we are live right now. Okay, so as usual, we'll be coding on the fly. You know the drill. Please, if I do something and you think there's a better way to do it, please kindly come off mute and just let us know so that we could all learn together and become better. And if there is something I do you don't understand, please remember you can always at every point in time call me back and I will really be glad to come back and explain. Right? So cool. So let's start. Now we okay, yeah, there's something I said I was going to show you. Yes, something I tried to do last week. I tried to show how keywords inside of functions are actually dictionaries because for Python, keywords are dictionaries. Let me just put that here as a note. So in Python, keywords are actually dictionaries. So this is how it works. Now, let's say I want to create a function called, let me just call it func A, all right, just for a function, anything, just call it anything, just because I just want to explain how this works. Remember when we talked about how to create functions, I told you that when you use double star and keyword arguments, what happens is that Python sees those keyword arguments as dictionaries. And that's why when we want to refer to these variables, we have to use keyword arguments dot items, which is like a Python built-in method that is used for dictionaries only. All right. So that's I just want to show you. Okay, so let's have this function A, and this function takes in keywords as arguments. And all this function does is to print out the keywords. All right, so let me run this. Okay, so I would come up with another line and then let me call that func A. And I'm going to put in keywords. So let's say country equals to Japan. And let's say states equal to Tokyo. I don't know if Tokyo is a state, I'm just writing. Okay. So now when I run this, you'll see that though I supplied keywords, when you call this function, what Python gives you is a dictionary. Yeah, so that was what I was trying to do last week. I don't know why this stuff didn't work last week when I did it, but I had to redo it again. I've noticed that thing. Sometimes you do something and it looks like okay, it didn't work. Then afterwards, we just do it and it works. So that's like sometimes it's like magic. I don't know why it happens like that. So so that's what this does. It just shows you that in Python, keywords are actually dictionaries. Key word. So like key and value. All right. So I just thought to get that out of the way. Now, one thing we're going to do right now is we are going to go into conditionals in programming. So if you remember very well, we talked about control structures. We talked about procedural structure, which states that you have to write your code in the order in which you want your program to run, as the way you want Python to run it. So the first step has to come before the second step and all of that. So that's procedural basically. But the second control structure is decisional, which happens when you have to make a decision. And usually you come into decision making where you have to when you have to decide on something, for example, and most times in programming, not just in programming, I think in real life, what happens is that when you want to make a decision, I think what happens is most times it's usually based on a Boolean structure. So if it's hot today, I'm probably going to go bungee jumping. All right. If it's cold today, I'm going to stay indoors. So we all have to now make those decisions based on that Boolean value. So the first thing that our inner programmer has to check is this condition true or false? The condition is true, then what do I do? The condition is false, then what do I do? Okay. So let me just use an example of temperature since we started talking about temperature. All right. So I'm going to create a variable called temperature. And this variable is going to be an integer that comes from an input that, the user is going to enter. So enter temperature here. All right. Okay, so now I want to do a conditional decision making stuff to say, okay, if the temperature is between 0 and 10, do this. Else, if it's between this and this, do this. Else, if between this and this, do this. So Python has just one basic conditional structure, all right? And it's just if, elif, else. In other languages, you probably have like 4 different kinds. I know in Java you have switch, case, you have if, you have I think you have about 3 or 4 of them in Java. Then Visual Basic 2, same thing. All right, but Python basically just has one. And the thing is this, Python usually, when it comes to all of this, Python adopts a minimalist approach, like less is more, there is really nothing you can do with your switch that you can do with if. Sometimes simplicity just works. So let me just put a comment here to just let us know what we are trying to do. So what we are trying to do is we are trying to create a conditional statement that evaluates the temperature and returns a particular what right now? Okay, particular decision. Yeah, so let me just use that. Okay, so that's the first here, temperature. So now we're going to use the if. So I'm going to say if temperature, all right, is greater than 0. I want Python to print, okay, so Santa Claus is coming to town because really it's really cold. All right. Obviously, when he comes from the North Pole, he comes with a lot of cold with him. All right. So I'm going to say Santa Claus is coming to town. All right. But if okay, so I'm going to say elif, which is to say, okay, what if that's not the thing? All right. Then the next thing I will do is indents. All right. I could even do this elif on the same line. Yeah, I should be able to do that on the same line. So elif temperature is, remember, I want to do a band of tens. So if it's 0 to 10, I want you to say Santa Claus is coming to town. If it's 11 to 20, I want you to, plan for spring break or something like that. So this is what I'm going to do. So let's say if it's greater, what I'm doing right now is wrong. I've been expecting that somebody's going to tell me that, but let's just continue and I'll run it and I'll tell you why it's wrong. And then I'll do the correct thing. So, so if it's greater than 10, what should Python do? Print it's a good day for the beach. All right. And then I want to also say else prints the weather outside is scorching. All right, so just this. So what I'm going to do right now when I run this is going to be very, very wrong. Okay, so when I run this, the stuff asks me, okay, so enter your temperature here. Now, watch, I'm going to enter 2. All right, and it's going to tell me Santa Claus is coming to town, obviously, yeah, because temperature is greater than 0, all right, but it's less than 10 where the next band is. So let me close this and run this again. Now, let's say temperature is 15, so I just enter 15. When I enter, it's supposed to tell me it's a good day for the beach, but it's still telling me Santa Claus is coming to town. You know the reason? The reason is simple. The same procedural programming thing I told you about. That Python will always consider the first line. You know, Python evaluates the code in lines, all right? So it will consider the first line and say, okay, if the first line is true, then there's no need checking all the other ones because the first line says temperature is greater than 0. Obviously, what you just put here is greater than 0. So let's need checking all the other lines to know whether this thing is true or not. So, or there's other, you know, other conditions that this same thing met. So, I mean, that's why it's giving this. If I enter 30, it's still going to tell me Santa Claus is coming to town. So how do we deal with quirks like this? Very simple. So I'm going to put a band here. So I'm going to say if temperature is greater than 0, and I'm going to use this keyword. And this is a logical operator. It's a keyword that evaluates 2 conditions, all right? So I'm going to say if temperature is greater than 0 and temperature is less than 10. So that fixes that problem. So I'll come to this place and also say elif, that's else if, according to some other languages, but Python makes it elif, all right? So elif temperature is greater than 10. No, okay, let me use less than or equal to 10 so that there's no overlap, all right? So if temperature is greater than 10 and less than 20, oh, sorry. Oh, what have I done? Temperature is less than 20, all right? Print, it's a good day for the beach. Else, print the weather outside is scorching. Now, this else carries everything that does not fall into this band. So, if the temperature is -2, can you guess what Python is going to print out? If the temperature is -2. Remember, the evaluation starts from here. So -2 is not greater than 0. So Python is going to leave that. Okay, let me just show you what happens. Let me close this and run this again so that you can see what happens if I put temperature is -2. So I tell me the weather outside is scorching, but -2 is actually freezing cold. But why it's like that is because I've told Python that once you don't see anything that falls within this band, whether on the positive or on the negative, just repeat this line, the weather outside is scorching. So how can we fix that? Anybody? Please come off mute. Anyone? Can anyone help? Okay, John.
You can put another line item in, another else if.
Okay.
That if it's less than 0,
okay,
weather outside is freezing.
Okay. Okay. So so that means we could, but could we possibly do anything to this first line? Is there any logic we could use to ensure it accommodates this?
Yes, yes.
Okay.
We could try just doing less than equal to alone without using the and. So if the first line will just say if temperature less than equal to 10, equal to 10, yes,
Okay.
eliminating any other one.
Okay, so this whole thing should go, right?
Then less than 20 and else.
That's one way. Yeah, we could also do way John suggested, both ways are going to work. And that's the beauty of programming. There are like 500 different routes to the market. So anyone works for you. All right. So both ways are going to work. It's cool. So right now, if we run this and we say the temperature is -2, then we get, yeah. So it takes care of that. All right. So that's how this works. If, elif, else. But again, another thing you should also note is that if does not have to go with elif. All right. And that's one of the things that drives everyone crazy about Python, because I mean, Python is so lax. Python looks like I think some people think that anybody that codes in Python is not a real programmer because there are no rigid rules, you know. So when we get to object-oriented programming, you're going to see why those guys from Java and C# hate Python with a passion, like, because the rules are crazy. And, you know, Python even allows multiple inheritance. Now, to let you know the ramifications of multiple inheritance, it's like saying a person, you know, belonging to the mammal class and also belonging to the dog class. Well, it's possible. I think Vampire Diaries, the werewolves who were humans, right? Yeah, okay. But basically you get the jerk. But some other languages don't allow that happen. You can't belong to two classes unless you're Damien from the Vampire Diaries. Come on. Okay, so now let's show how one of these quirks in Python works. So if let's just use yeah, one of the things I would also want to say at this time. Okay, let me finish this. I'll show that. So in this place, I could say age equal to an integer that comes from an input, enter age, sorry, here, right? So now I say if age is, let me use this, if age is greater than, age is greater than 20, print, okay, so I'm gonna print boy, you are old, all right? Exclamation marks. Okay, so cool. Now, you would notice that there is
I should start crying, right? Let's start crying because I'm older than 20.
Right.
I don't understand.
I think there is nobody here that is younger than 20, so we are all old, right?
I'll start crying.
Okay, so now what this does is that let me just run this. If I print 21, now it's going to evaluate for me. Cool, all right? But what if I do 15? What do you expect this to return? Yes, somebody guess. Because I did not put another value that Python should balance it. Nothing, right? Okay. Any other person? Nothing. And this is one of the quirks in Python. Like, why? Travesty. You know, because you shouldn't run a line of code and it evaluates nothing. But the truth is, there are actually times when you need this nothing to happen. And we are going to encounter them as we proceed into the session. You know, as we proceed on our Python journey, you're going to encounter some of those times where you really are hoping from your mind that nothing happens. So that's another plus for Python. All right. Now, let's talk about while.
Before you go to that
ahead.
real quick
Go
question
ahead, John.
there's no end if or any ending statement required here. It's just once you stop the indent, your if statement ends.
Exactly.
Okay.
Yes.
Okay, thanks.
All right, cool. Yeah. Okay, so we've talked about if statements. Now, that's the only thing in Python you use for conditional decision making. So let's go to the next of the control structures, which is repetitive or looping for decision making when you have to do a task an uncertain number of times or a given number of times is very sure. Okay, so let's talk about loops, which are like the third control structures. So loops. Now, there are two kinds of loops. There is the, okay, so let me just call this a loop with finite steps, as in from the word go, you know how many steps you have to take, all right? And then loops with non-finite. Now, non-finite in this case doesn't mean it goes on to infinity, but you don't know how many steps you're going to take, all right? I remember when I was young, so if you just leave me alone in the house, I probably am going to sleep off. And well, for my elder brother, you could knock 3 times and you'll be sure he will wake up, no matter how deep he's sleeping. I don't know how he does that, but I think he's just a cat of a human being. All right. So if you're going to write a code, maybe you want to program a robot that is going to come and knock on the door and, you know, get somebody jacked up to wake up. If you're writing that code for somebody like my brother, you just say, okay, knock thrice, and on the third knock, obviously, the person is going to open. So the repetition is finite. You're going to program it to repeat just 3 times, all right? But if you are programming that robot for me, oh boy, now that is going to be non-finite. So how you write that code is this. While Ugo is not responding or is not,
Sorry.
Yeah, go ahead.
We'll write the code with pour water on him.
All right, so you're going to write the code like, while Ugo is not responding, continue knocking. So he just has to continue knocking until the response that he wants is, you know, gotten. So that's what we mean by finite and non-finite loops. And in Python, finite loops, you use for to deal with them. For non-finite loops, you use while. All right, so yeah. Now, there is the one called infinite loop. All right, like it just goes on to infinity. Let me show you one of the things that makes an infinite loop happen. So now, let's say I'm trying to program, I'm just trying to write a code, you know, to monitor Oge's hunger. All right. Now, so while Oge hungry is equal to true, I want Python to print, please feed, oh, come on, please feed Oge. Okay, so do you know what this is? It's just saying that as long as Oge is hungry, which means that Oge can be fasting, Oge can be like, I don't want to eat. Maybe she's on hunger strike or something. And while she's not eating, as long as that not eating is true, okay, please, Python is going to print, please, and I'm going to run it right now. So this is what Python is going to do. Okay, Oge hungry. Okay, let me define Oge hungry right now. Just a second. So let me say Oge hungry equals, let me use true. All right. So yeah. So while Oge hungry is true, print please feed Oge. So you can see this thing just keeps running infinitely. It's not going to stop. And this is what you call an infinite loop, because it just continues running and running and running and running and running until it crashes your system or till something happens. So that's one of the things you want to, you know, we want to check where I want to make sure that no infinite loops runs in your loop. So how do you deal with this? Okay, so let me just terminate this. I'm just going to interrupt this. Okay, so interrupted. All right. Now, let's talk about how to deal with your loops, whether for loops or while loops, so that you don't create infinite loops and then, you know, you follow the real Pythonic way of doing loops. All right. So now let me introduce a new loop, a new cell. So let's talk about, this might be a good point to introduce things like range, enumerate, and a couple of that. Okay, let's look at this. Now, let's say I want to print out numbers from 0 to 10, all right? So I want to print out numbers from 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, this is what I'm going to do. Python has a keyword called range, all right? And what range does is that range takes whatever you put inside of it. Let me get the syntax out. What it does is it takes what you put inside of it, let's say starting from 0, and then the end is 10. And maybe you just want to move it in steps of 1 each, all right, which is the default, but you can move it in steps of 2, in which case you get 0, 2, 4, 6, 8, 10, 12, like that. Come in steps of 3, which is 0, 3, 6, 9, 12, like that. So, but if you don't put anything here, then it means you want the default to be 1, all right? So if I tell Python to print range 1 to 10 for me, so this is what Python is going to give me. Oh no, come on. It's going to give me range objects. Let me see if I make it a list, whether it's going to make a difference. Oh yeah, okay, so now that's one of the things with Python. So whenever you generate something like that and it brings out just an object for you, and we're going to see a lot of times when it brings an object, you might either have to convert that object to a list or to a tuple or a dictionary or whatever kind of data structure that you like, so that you can see what is inside instead of just seeing the object itself, all right? So that's what Python does now. So it tells me, okay, this is what you have: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, let's make this a for loop. So let me just introduce another cell. Oh, did I just delete that? Come on. I did. Oh no. Okay, so let me introduce another cell. It's not coming back. Let's see. Do insert cell, undo delete cell. Okay, yeah. So let me add this code cell here. Now, a for loop, the structure of a for loop is usually for x, or let me use the word for iterator in iterable, all right? What should Python do? Iterator in iterable, come on, I didn't say items. So for iterator in iterable, what should Python do? Print, calculate, return, anything, all right? So at that point, you could just decide what you want Python to do. It's not really fixed, you know. Anything you tell Python to do is what Python is going to do at that point in time. So why does Python do this? Very simple. You can use the for loop to run through finite steps. So remember, I told you anytime you're using the for loop, you have to know the number of times Python is going to iterate over the object, all right, that you're iterating. So in this case, if we run and we say, okay, so if we say for numbers in range 0 to 10, all right? So say from numbers to range 0 to 10, print numbers. Okay, so I'm going to explain this right now. In Python uses a lot of placeholders. I'm sure you have noticed that. These numbers can be anything. In some texts, you would have seen people write it as I, for I in range, or for J in range, or for X in range. It can be anything. You can even say for John in range, or for anything at all, all right? And Python is fine, because Python knows that after the for statement, whatever is there is just a placeholder for the iterator. So what is the iterator? The iterator is every unit inside the iterable. The iterable is any data structure, a collection or whatever that can be iterated upon. So there are a lot of things that are iterable, things like lists, things like tuples, dictionaries, even strings can be iterated upon. So let me just show you an example of what I mean when I say iterable. So any iterable, anything that Python can count over, all right, is an iterable. So let's do that right away now. Let me just say name equals, let me use Sima, all right? Now, I could run this and yeah, Python says no problem with that. Now, I could also say len, I'm asking Python to count how many items we have in names. So it's going to count it and tell me we have 6 things inside of name. Anything that Python can use this len over is an iterable. So let's even say I make a list here because this was just a string. So yeah, you can use this. Let's say I make a list. Tina, John, I'm gonna put this strings and Demola, and then just close it. Okay, close it here. All right. So now when we run this, again, Python is not going to have any problem with that. But when we run this now, you would see that we have 3, in which case Python has iterated over the structure and has told us that there are 3 items inside. So whether we have strings or lists or tuples or anything, all of them are what Python sees as iterables. All right. So with that, we go back to our for loop and let me just move this up so that it doesn't block our view right now. So let's come to this place. So for numbers in range this, so we're telling Python for all the numbers that you have there, print numbers. So let's run this. Yeah, so this is what Python tells us. It prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So there are other iterables you can use. You can even say, okay, so we have names here. So we can say for name in names, which is what we have above here. All right. Print name. So we're telling Python for every name we have in this iterable, all right, print name. Now, I hope this doesn't give me an error. Let me use for students. Let me add something because name, it could be a reserved word. So let me say for student name in names. All right. So since we're all, yeah, so print, and let me use not student right now. Let me use attendee or participants. Or student makes it look like a school. Participant name. Yeah, so for participant name in names, since all of these are participants, all right? Print participant name. Okay, so when we do this and we run it, boom, it gives us the participants' names. Let me delete this so that's just goes away. Okay, so so far, do we have any questions? Is there anything we need to pause and look at? I will be glad to stop the class at this point. But if none, hey, we'll continue having fun. Anyone? Right? Okay, so if no one is saying anything, I'm going to assume that we're all great. Now, okay, so let me go. Let me do something. So far, we've looked at very easy data structures. So let me introduce a data structure that could be very wonky to deal with, dictionaries. For a while, dictionaries were like my kryptonites because sometimes they could be very wonky to deal with. So let me say, no, come on. So participants data, all right, equal to So I'm going to assign participants details. All right, so I'm going to say participant 1. All right, or let me make the 1 a string, and I'm doing that carefully because why I'm using a string as that 1 is because it's not a number. I don't want to iterate over it or run a sum or whatever, any arithmetical operation on it. So the rule is this: any number that is not supposed to be used for arithmetical operation should be carried in your Python code as a string. All right, it saves you a lot of stress because one day you might get to the point where you run a particular code and that code just goes to pick what you have there as a number instead of string. So I'm going to say participant 1. Participant 1's name is, let me see, Demola. All right. And comma, I'm going to participant 2. And participant 2 is, let me see, Ashwini. And a comma there. I'm going to put participant 3. I wish I could put everybody's name right here, but just for the sake of time, I'm just going to stop at 3. So let's take no row as participant number 3. All right. So this is a dictionary now. I'm just going to run it and it's going to tell me, hey, there's no problem with this. Okay, so good. Now I want to fetch a value in this dictionary. And this is where things begin to get hairy, very, very hairy. So let's start. Now, let's say I want to get just the values, all right? So, and I want to iterate over this dictionary to extract the values. You know, I could have like 10 of them, all right? Or 20 of them, or even 100 of them, especially if you deal with JSON files. Side notes, JSON files are just Python dictionaries, okay? So just same data structure, no difference at all right? So if you deal with these files a lot, or you deal with dictionaries or data that's been coded with key values a lot, sometimes you would need to iterate over all of them and pick out some things. So how do you go about it? Very simple. Let's iterate over this right now. So if I want to get just the names of the people, not their registration numbers or their ID numbers, which is the 1, 2, 3. How do I go about it? I'm going to use a for loop and say remember, every dictionary has a key, which is the ID number or whatever, and the value, which is what it returns, all right, when you call that. So we'll say for key and value in participants data, okay, participants data. All right. What should Python do? But remember, because this is a dictionary, if you run this like this, you're going to get an error. I'm going to show you why you get an error. I want Python to, okay, print just the values, which is the, yeah, okay. So I want Python to print the values. If I run this, I'm going to get a big error, very big error. And the reason is simple. Python is telling me, don't mind this gibberish you're saying here. What it's actually saying is it's trying to unpack this dictionary, but I didn't tell it what to unpack. So what deals with this? I'm going to tell it I want to look into the items because that's the method, the dictionary method, you can say it, that you use to view items inside a particular dictionary. So what is happening here, you're telling Python is this: for every key and value inside this collection, the whole collection, the items in the whole collection, I want you to print out just the value. So when I run this, bam, it gives me all the values like 1, 2, 3. All right. So I could even say print key, and it gives me the keys. Okay. So now what if I want to make these keys or the values? Let me take it back to values. What if I want to use these values for something? So maybe, oh, not values, come on, value. maybe I want to use the first two names, all right, in the value to run a code or just do something. How do I do it? There are two things you should note about Python functions. When you're writing a function in Python, whenever you need a function to create an object, you have to name that function as a variable. So for example, let me use this len now, okay? So let me say len, let me say len names. Okay, let me use this names again. Sorry, I'm scrolling. Now, when you run this len names, it gives you 3, right? But then when you want to use this 3, when you want to use this result in to perform something else, all right, you will have to give this thing a variable name. So you can call this results or calculated anything. I'm sorry, calculated length, yikes, equal to len names. All right. Sorry about the variable name. It's just what came to my head right now. So when you run this, now you notice you don't have anything because Python, whenever Python assigns a variable name to a function or a method, it doesn't yield any output until you call that thing. So now I can now say, print 1 plus calculated length. And guess what? Bam. Yay. All right. So it's Python's way of saying, hey, you want to use this variable for something good, or you want to use this function or this method that you're applying, you want to use it in the future and you want to be able to call it, name it. But in this case now, because this is a for loop, and a for loop is not like static, a for loop generates things as it's running. The only thing you can do is you will have to create a collection on the fly, where as the for loop is generating that stuff, is throwing that result, all those results into that collection. All right. So let me explain what I mean here. I'm going to just put up a new space for a code here. And then, so let's say we want to use these names that have been generated in the value. What I'm going to do is I'm going to create a new list or a tuple or anything, any data structure at all that I want. So let me call it, the choosing names. How do my variable names? Sorry, because they just comes into my head that I just put. So let me call this chosen names, and I'm going to make it an empty list. All right. So let me move this up here, so that remember, procedural structure is what you want Python to do in the order you want them to do. So I want to create chosen names, and I'm creating that right now. Come on, run. So it needs to run and tell me, okay, yeah, cool. So no problems. So now I'm going to tell Python that for key value in participants or data items, I want you to, instead of printing the value, I want you to append the names as you're generating, because the for loop is a generative process. So as you generate, I want you to append it into that list, all right, called chosen names. So that by the time you're done, when I run it, I'll see all the names you append. So in this case, what I'm going to say is chosen names dot append, and I'm going to tell Python to append the value that you're getting, all right? Because these are the values. So Python, as you generate these values, instead of printing them out here, just append them to this list. So I'm going to run this, and Python says no problem. So now I'm going to open a new line of code, and I'm going to call chosen names. So when I run this chosen names, let's see what comes out. Hooray, the names of everyone who are, have been appended. So now, because this is now a hashable data structure, and when you hear that word hashable or subscriptable or whatever, it just means that you can use index numbers to refer to these items. So if I wanted just the first two names, all right, I would have, I could just write a code that says, hey, Python, generate so and so for me. But after it generates them and you append them into chosen names, I want to just print only chosen names. Okay, let me use this one. Chosen names. The first item in chosen names, and that's what this one means. And the last item in chosen name. So that is item number 2. Okay. So that way, when I run it, I'm good to go. Okay. So I don't know why my collab just keeps disconnecting and reconnecting on its own accord. I don't know why that happens, but I'm going to look for why it happens and who I offended, and I'm going to beg them to forgive me so that this thing can keep running without disconnecting, because it just keeps disconnecting like almost every second. So come on. Okay. Yeah. Oh no. Okay, so while I wait for this guy, I'm now thinking I should switch back to my regular Jupyter notebook, because this is now becoming embarrassing. Very embarrassing. Please. Please. Okay, so I think the gods have decided that we have to switch to vanilla Jupyter notebooks, and I'm going to send you. I actually thought using Colab is going to make things easier, and just so all I need to do at the end of this session, I just copy the link and paste it, and then we just keep populating and working on it. But it seems the gods are not in favor of that idea, so I am just going to get this done with. I'm just going to open up a Jupyter notebook. So let me open up a vanilla Jupyter notebook, and let's deal with, oh no. So sorry about this. Should have, yeah. Okay, so I think Jupyter Notebooks is up, and we will switch straight up. Okay, so but so far, do we have any questions? Any questions, anything we should look at together? Do we have any? Now, one more thing to do is that I would like to see, okay, we've not talked about while loops in the open web sense, so let's go to while loops. All right, so let's do while loops. So let's put a code cell and while loops. All right, so how do you avoid having an infinite loop? Most times, I encourage people to use while loops and have something called an index counter. All right, so okay, that's tautology. Indexer or counter. So what does this do? Very simple. It just keeps track of your steps. all right? So that you don't have to fall into that infinite loop, you know. So let's say that we want to say, okay, temperature. Let's say we want a piece of code that will check the temperature, all right? And while temperature is less than 30 degrees, it prints out it's very hot in here. So let's do just that. So let's say temperature would be an integer generated from an input, and enter temperature here. All right. Okay, so now we want to say while temperature is less than 30, prints the weather is sunny or the weather is fine. Sorry, weather is fine. All right. So what this means is that when you want to evaluate this code in Python, it's going to check for the temperature. And if it's less than 30, as long as it's less than 30, it just keeps printing out the weather is fine, the weather is fine, the weather is fine. But this is bad code because it's going to lead us into an infinite loop. So how do we deal with this? We will add something called a counter, all right? So let's call this a step counter or something. And then let's initialize it at 0 or 1, anyone you do is fine, okay? So I would say while temperature is less than 30 and step counter is less than 10, because I probably just want this to check 10 times, all right? Or no more than 10 times, you know. Print the weather is fine. And then update the counter. So you have to update the step counter plus equal to 1. All right, this is just shorthand from saying step counter. The new value of step counter will now be step counter plus 1. I could write it this way so that it doesn't confuse you. Step counter equals to step counter plus 1. So I'm just saying, once you print this, update the value of step counter to step counter equals to 1. And then, so as long as the step counter is less than 10, then just keep printing. So let me run this and let's see what happens. Now, enter temperature. Let me enter 30. No, 25, which is less than 30. All right. You'll see what it will do. It will print out the weather is fine 1, 2, 3, 4, 5, 6, 7, 8, 9 times, and then exits the whole thing completely. All right. So that's what. If not, if you don't add like an indexer or a counter, then you're going to have an infinite loop as long as temperature is below 30. So that's one of the ways that you can use to escape from having a while loop that runs infinitely. Okay, I won't believe that that is fine, but if it's not, you can always just pause me and I will be glad to come back. All right. So now let me proceed to the next thing, which on my list, let me see what's okay, we have while loops, then what else should we do? Okay, yeah, let's talk about control statements. Okay, so now there are some statements that you could use to control the flow of your program. There are a lot of them, but the most popular are break and continue. Okay, break, continue, and pass. Okay, so let's see how these three work. So let's start with, let's take a for loop, all right, for example. So for number, okay, let me use number in range So let me use 0 to 10. Okay. If I want to tell Python that if you start counting, all right, and you get to the point where number becomes 3 or number becomes 4, I want you to exit the loop completely. Just terminate and just, let that be all I get from the loop. So in this case now, normally if I run this for number in range 0 to 10, it's going to print 0, 1 to 3 to 9 for me. But I don't want to get the whole 9. I just want to get the first 3. All right. So I could do that by saying if number is equal to 3. All right. What should I do? Break. Okay. Let me see. I think there's something I need to add here. So for number in range, this. Okay, let me try this. I've not tried it this way before. Print number. And then if number equals to 3, break. Let me see what it does. Let me see. Oh, great. So it works. So what I've just told Python is this. For number in range 0 to 10, print number. But if the number is 3, once the stuff gets to number 3, I want it to break. All right. Break means exit the loop at that point. So, but if I remove this line of code here and I run this, it's going to print the whole stuff for me. But now I'm telling Python, okay, so now as you're printing this number, the moment you get to the place where the number is 3, break out and get out from there. So I just need all the lines from where it gets to 3. Now you use this as an alternative to indexing, all right? Yikes. Okay. So you use this as an alternative to indexing and to be great. Okay. So yeah, let's take it a notch higher. Now, the second statement you could use is continue. And this is an unfortunate statement because if you ask me, I would have suggested that Python call this skip instead of continue. So what this does is, if I say if number equals to 3 and I say continue here, I'm just telling Python, when you get to that point, skip what is there and continue the loop. So let me run this and you see what's happening. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, this is not what I want to get. So let me use this. Just a second. So let me say okay, let me use a block of code. Let me use a block of code, like say let me say number. Let me use this. Let's say okay, numbers equal to let me use a list or a tuple. Use a tuple. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if I'm so sorry. For how long was I gone? I kept talking. I thought I was still in class. Oh boy.
Just about 10 seconds was all, pretty quick.
Okay, I'm so sorry about that. I don't know what happened right now, really. I just think that it's just weird. Everything just disconnected. All my internet devices just disconnected. So I don't know what happened. All right. So so let's say let's say for number in numbers, all right? Okay. If number equals to 3, skip, and then you, okay, so let me run this and let's see what happens. No, nothing happens. I supposed to say prints here. Print number. Okay. But if number equals 3, why is this print not highlighted? Something is happening to my collab and I don't know what's happening. Let's see. What's happening? Print. Okay. Print number. If number is, let's see how this works. No, this is not what I want to do. This is not what I want to do. Okay, I want to jump this. Okay, you know what? I'm going to get another example that works with this perfectly. Right now, I don't know what's happening, but I'm going to get another example. What I'm trying to do is if number equals to 3, all right? Skip. But let me see if break works here. Let me see what happens. Okay, yeah, it breaks at 3, but then why does it not skip? It ought to skip 1, 2, 3, 4. It ought to skip this one completely, this number 3. Okay, but like I said, I'm going to check and I'm going to put it in the collab that I'm going to send to you. I'm going to correct that. All right. So then the third control structure is pass. And what does pass do? Sometimes you might write a function that that requires something done. Okay, so and in that case, when you write that, for example, you write this for loop. Okay, I don't know why you copied the whole thing. So, but you just want this for loop to run as, but you don't want it to do anything when you're writing the code. Or you can't just leave it like this. So either you have not decided while you're writing the code, you probably have not decided what you want this for loop to do. Maybe you want it to print or you want to return a particular value or something. All right. You have not decided what you want the for loop to do. So what you use is the word pass. Once you put this, Python allows the programs to continue running and just, ignores that this code is not complete. If you did not put this pass, Python will not allow you go. So pass is like your tickets, all right? So just say, hey, allow me pass. I've not decided what to do to this code, but so you'll see this a lot, especially when you get to object-oriented programming, when you're still deciding, okay, what are the features of this object going to be? And you don't really know because you have not like decided up front. So you probably want to build it on the fly as you work. That's when you use this statement pass. Okay, so those are the control statements that we are going to look at today. And if there's still time, we could look at, I know there's no more time. Okay. So right now we'll have to take questions. But if you guys want to, we could take one more thing and we could now call it a day. But else, it means we'll have to look at this next week before we start object-oriented programming. I am so hoping that we could start that next week because that's where the magic happens. The beauty of everything we've been learning. That's where it happens, right? So if you have any question, I'll be glad to take it right now. And there's some people who are joining us for the first time.